percentile value. We're going to look at P sub k, which is the kth percentile. It's the value, it's a data value such that k% of the observations are less. So k% of the data is less than P sub k. Okay? So in other words, P sub 50 is the value such that 50% of the data is less than P sub 50. And by the way, P sub 50 is the median. It's also known as the median. All right? Let's look at an example. Here we have VO2 max for a bunch of athletes, Nordic skiers, who are known to have the highest VO2 max, elite Nordic skiers, that is. It's a measure of the rate at which you can consume oxygen. So it's milliliters per kilogram per minute. So milliliters per minute is the rate, and then per kilogram normalizes it for body mass so that you can compare athletes of different weights. Okay, if we're going to arrange this data in ascending order, right? So P sub 50 is the median. It's the value where half the data are less. Well, we know that when n is equal to 20, it's even, and the median is going to be halfway between the two central values, the 10th and the 11th. So it's going to be halfway between 71 and 71.6, or 71.3. So that's the 50th percentile. So P sub 50 here is 71.3. That's pretty, milliliters per kilogram per minute. Okay. Now what happens if we don't have such convenient values? Well, we have a formula. Here L is the locator in the position in the data, as you arrange low to high, of the kth percentile, and n is the number of data values. Now, if you look at the flow chart in our text on page 116, it turns out we have to do different things if depending on whether L is a whole number or not. So if L is a whole number, P sub k is midway between the Lth and the L plus first value. We just saw that with the median, right? So our example here was P sub 50, and we found L was equal to 50 over, well, we just did it by inspection, right? We found the median, but here's how the formula would work. So if we work this out, we get 10. So L was a whole number. We saw that the median was the midpoint between the 10th and the 11th values. So we took the midpoint. So that's what we do when L is a whole number. We take midway between the Lth and the L plus first value. If L is not a whole number, we round up. So for example, if L turned out to be 8.2, we would take the 9th value in the data. Let's do an example where L turns out not to be a whole number. Example where we don't get a whole number. Let's find the 31st percentile for our data. Now we're going to find L equals 31 over 100 times 20, or 0.31 times 20. Not a whole number, so we're going to round up to 7 and take the 7th value. Right? So we're going to go down and take the 7th value, so 70.2 is our 31st percentile. So 70.2 milliliters per kilogram per minute. Always remember the units. So we've used our formula to find p sub k, the kth percentile. That's one type of problem that we can do. So we did an example of that. The other type of problem is where we want to determine the percentile value of a given data value. So we want to find k. So if we want to find k and we're given the data value, then what we want to do is rearrange this formula as follows. So we're going to be solving for k. And so k is going to be 100L divided by n. Do we see that? So we multiplied both sides by 100, and then we divided by n to solve for k. Recall that L is the number of data values less than a given value. So let's determine, go back to our VO2 max data and determine the percentile of this data value here. Okay, so 72.9 milliliters per kilogram is in which percentile? What's the percentile value? Okay, well what we do is count the number of values less. Okay, well these are all less, so there are 14 of them. So L is equal to 14. So we have L equals 14, so K is 100 over 20 times 14. And we can do this handily in Excel. Divided by 20. So our data value is in the 70th percentile. Where's our data? Oh, here it is. Okay, so our data value is 72.9. So the percentile value of 72.9 is 70.